we are again. I have no idea what's going to happen with our learning, but we're back at my back garden chalkboard. Now, I've changed it to a chalkboard because on the reverse of my daughter's whiteboard, she actually has a blackboard. So you might as well learn it the way I did back in 1975. So I'll be able to make loud squelching noises and squeak and break chalk and be generally annoying. So the thing we did in the last video, the first video, was to have a look at a much simplified way of representing hydrocarbon molecules. And let's just do one of those just to see that you remember what was going on. So if I'm to draw that, and I asked you to name that, you'd see that there's no double bonds here, it's just a zigzag line, it's an alkane. And all we do is 1, 2, 3, 4, 5, 6, 7, 8, and you can see that it is, in fact, octane. What we're going to do now is we're going to build on this simple model, and we're going to add some functional groups. And I think the easiest way to add some functional groups is simply to add some halides. And that just means group 17 atoms. We're going to add, say, chlorine atoms or fluorine atoms, bromine or iodine atoms, that sort of thing. And we can add those simply to one of these hydrocarbon structures because each of these group 17 elements, they've got 7 outer electrons, valence electrons, and so they need to form one covalent bond in order to achieve stability by making that octet arrangement. So let's start from the simplest of the hydrocarbons with methane or methane, and we'll have a look what that becomes. So here is our methane in the old-fashioned way. It's just amazingly dull in the new zigzag line way, and obviously we can't represent that with a zigzag line model because it looks like that, which doesn't help anybody. But let's see what happens with this very simple hydrocarbon if we just do this. Alright, and that is now chloromethane. Now, I didn't leave myself much room there, but you can kind of read it. So that's chloromethane. And then we do the next bit. If we add another chlorine there in place of another hydrogen, it becomes dichloromethane, trichloromethane, tetrachloromethane. So the familiar prefixes when we add a halogen to there, which is now a halide, and that's now tetrachloromethane. So let's have a look at what we can do with a more complex one of these. So let's start with butane. Let's go to butane. And once again, I'll draw this the old-fashioned way just for a while. And then we'll draw it in the new-fashioned way, and then we'll name it. So here's butane. And let's have a look how we can change this by adding a halide to it. So let's try adding a bromine atom there. And now that would be called bromobutane. But there's more to it than that. And the reason there's more to it than that is that a butane molecule with a bromine attached to the first carbon is going to react slightly differently from one with a bromine attached to one of the central ones. And so this becomes 1-bromobutane. If we were to take that butane, that bromine, and add it to this one, this would also be 1-bromobutane. We simply take the smallest number from one end. So this is now 1, 2, 3, 4, instead of the other way round, which is what it was before. But if we were to take that bromine and add it to here, that would now be 2-bromobutane. That's pretty simple. Let's have a look what would happen if we added, let's see, a chlorine atom there. Now, I've got to scrunch this up a bit, and that is now, have a look at which carbon the chlorine is attached to, and it becomes 1-chloro 2-bromobutane. It's really quite simple and systematic. And how would I represent that on the zigzag type diagram? 1, 2, 3, 4. There's my butane here, and I have a chlorine attached to that one, and that is the second carbon, and that becomes a bromine. Look confusing? But wait, there's more. Let's try one more of these and have a look at another way of naming these in a little while. Now let's draw a pentane. Alright, and we've got that. And I'm not going to bother with drawing all the carbons, the hydrogens there, because that is an extremely dull thing to do. Let's now look at, let's have a bit of fun with this. Okay, so we do the smallest number from the end, and that one's going to be 1, and there's 2, 3, 4, and 5. So, how many chlorines attached to that? Tri, and that is tri-chloro, 1, 2, 3, 4, 5, pentane. Now at this stage we've got 3 chlorines there, and we have to give each of them the number of the carbon atom they're attached to. So we can't just write 1 trichloropentane. We do this: 1, 1, 1 trichloropentane. A complex looking way of doing it. Let's see how we do it with the zigzag structure. I've lost count. 1, 2, 3, 4, 5. Ah, that's good. And then we just do Cl, Cl, Cl. Those are supposed to join. And so here, let's see, here is carbon 1, 2, 3, 4, and 5. So there it is, 1, 1, 1, because they're all attached to the first. Trichloropentane. What an awesome molecule. Okay, I'll give you some exercises to do with these with a fairly official looking university site which does its diagrams a lot better than I do. Okay, have a lovely afternoon and stay healthy.